Alright, so we're going to go over what we went over in class today, so you have a video lesson of it as well. I'm just pasted in something that I created in Desmos really quickly right here. So this is the function right here, f of x equals 3x squared minus 5x plus 4. I've got the graphical representation. And then the standard form of a quadratic we went over today is f of x equals ax squared plus bx plus c. Remember that we include our signs. Then also please remember that before we can plug this into a quadratic formula, we have to set it equal to 0. So both of these would be equal to 0. Now, for a, we have 3. For our b, remember to include the sign, it's going to be negative 5, not just 5. And then for c, it's going to be a positive 4. And we have that all equal to 0, right? What we're finding when we do the quadratic formula is the x-intercepts, if they exist, right? Or we'd have I if they did not. So we would set y equal to 0 to find that. So our quadratic formula then is negative and b plus or minus the square root of b squared minus 4 and then a and c. Extend this line slightly. All over 2 times a. Now what I wanted you guys to remember is we could split this into being negative b over 2a plus or minus square root b squared minus 4ac all over 2a in the same way that we combine or add or subtract with like terms. We can also split and have them both have that denominator. However, you need to remember that negative b over 2a is the x coordinate of the vertex or the axis of symmetry. So any way that you can remember that is fine, but remember that negative b over 2a is the x coordinate of the vertex, x for the vertex, or the axis of symmetry of, we'll just type sim for now. So that is what we get right here. And then the plus or minus moves it left or right to our x-intercepts. So if we're gonna plug in here, let's do our way of doing it. So we're gonna have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. We'll scroll down a little bit here. And then we can plug in our values, right? So we have negative 3, negative 5, and 4 representing a, b, and c. So b is going to be, looks like negative 5. So a negative negative 5, right? When we plug this value in, this negative does not go away. Over 2 plus or minus the square root of b squared. We had, what, negative 5 squared minus 4 times a, which was 3, times c, which was 4. And we can extend this out a little bit more. All over, and this is going to be the same 2a. So 2 times 3. Okay, so from this point we're going to simplify this down. negative negative 5, that's just going to be 5. 2 times 3, that's going to be 6. Plus or minus the square root of negative 5 squared is going to be 25. So when we take a square, it's this number multiplied by itself this many times. So negative 5 times negative 5 is 25, because when we multiply two negatives, we get a positive. Then we have negative 4 times 3, that's negative 12. Negative 12 times 4 is going to be negative 48. So what I'm seeing some of you guys do is we're confused about how to do this 3 multiplies in a row. Just take it piece by piece. Right? So when we got 4 times 3, that's negative 12. We still are multiplying by that 4, so that would equal negative 48. Alright, just a little side note over there on that. And then we've got 2 times 3 again, which will just be 6. So we did this separately so that we could really call out this right here. This is our negative b over 2a, our axis of symmetry, or our x coordinate for the vertex. So let's just put that right here to signal that we have it now. 5 over 6. And then we can continue going through our quadratic, simplifying it further. So there's nothing more we could do to this side, although now that we have already gotten our x coordinate of the vertex, we can combine them. They have the same denominator, so that'll make this a little simpler. So 5 plus or minus the square root of 25 minus 48, negative 23, all over 6. Now recall that when we're trying to get rid of a negative under a root, the square root of negative 1 is not possible, so it is a imaginary solution. So our final simplification is going to be 5 plus or minus I root 23 over 6. And we cannot do anything more than that. So knowing that the solution is imaginary, that means that we should not see x-intercepts when we go look at our graph from Desmos. And we see that is true. If this is our x-axis right here, right along here, we don't see that there is any intercepts there. The quadratic is all above that line. So what do we still have left? Well, we found our x-intercepts, we found the axis of symmetry, right? What's the line coming through the middle of this. So that would be right about here. So we found this axis of symmetry. But what we don't know still is we don't know what the y value is here. We still need to find that. So to find that, we're going to take this x value that we found, and we're going to plug it back into our function up here. So let's see what we get. We're going to get f of 5 over 6 is equal to 3 times 5 over 6 squared minus 5 times 5 over 6 plus 4. We're looking at about 1.92. 1.92 for our y value when x is 5 over 6. So let's see if that makes sense. If this is our 10, and we have 1, 2, 3, 4, 5 blocks here, that must mean that each one of these blocks is about 2. This is also about 2. It's just slightly less, right? 0.08 less than 2. So we would expect our vertex to be somewhere around here, and we see that yes, our vertex, or that y value, intercepts our axis of symmetry at what we can perceive as the vertex or the minimum point of this quadratic.